Let's use what we've been talking about with our angle pairs when lines are parallel, and we cut the lines with a transversal, and it creates some different kind of angle pairs that we know when these angle pairs, like corresponding alternate exterior, alternate interior angles, when they're congruent to each other, we know we have parallel lines. So this illustration here does a pretty good job explaining how, say, like alternate interior angles, this purple angle and this purple angle, alternate interior, are congruent to each other. And it looks like to me like we could take one of these angles and rotate it around a point to make it map right here. In rotations, remember, we keep the same size and relationship, so when you rotate an angle, it's just going to be the exact same angle measured down here, right? Same deal with these darker angles. If we rotate around a point, probably the same point as these purple angles, right? And actually, if you think about it, maybe that point's right here in the middle between the two angles, right? In the midpoint maybe of this segment that connects the intersection points. That looks to me like that would be a 180-degree rotation, right? So we're going to check that out. Same deal with the alternate exterior, like say this pink angle and this pink angle. If we found the midpoint, I bet you, midpoint because it's going to be the same distance from each angle, and that's what we need for rotations, right? If we rotate 180 degrees, I bet you this shape will rotate right here, this angle. Okay, corresponding angles, it looks like that all we have to do is just translate angles to create its corresponding angle, and we can make parallel lines that way. So let's check that out with GeoGebra. I got two problems here we're going to do together, and then you can get some practice in constructing parallel lines, and I'll give you an angle pair to use for each problem, like this one. Use corresponding angles to construct parallel. That's going to be parallel to this line AB and go through C. So here's what we have to think. We have a line, and we want to construct a line parallel to it. Our eye needs to be able to visualize right now that the line's going to look something like this, right? So what we need is a transversal. And since my parallel line is going to go through point C, and I'm going to use angles and stuff, I'm going to use point C as part of my as a point on my transversal. Okay? And then I'm just going to pick, for convenience sake, either A or B since they're already up here. Maybe A. I'm going to use A as the other point on my transversal. Okay, so now that we look at this blue line here in the transversal, we have four angles that are made. So if I want to do corresponding angles, all I have to do is highlight one of these four. Now, how do we highlight an angle? I'm going to use the polygon tool here, okay? And what I'm going to do is click on, say, A, and I'm going to highlight this upper angle right here, okay? So what I'm going to do is put a point on one side of the angle, and then put a point on the other side of the angle, and then back to A, and it makes a little triangle. But what's important about this little triangle here is that no matter what my side lengths look like, I have this angle captured in the triangle, right? And that's my angle that I want to transform so that I can get a parallel line, right? Its corresponding angle, which means that if I have a line right here, then this upper left angle would be the corresponding spot. So all I have to do is translate this triangle, which is really all I care about really is translating this angle to this point C. Let's try that. I'm going to grab my vector tool in the line toolbox. Okay, vector between 2 points. I'm going to take the vertex of the angle, that's point A. It's going to translate to C. That's where we're going to create the new vertex of our new angle here. And now I have my vector set. It knows the length of how long we want to slide this triangle. So I'm going to grab my translate tool, click on the triangle, and then I'm going to click on that vector. And now we have translated that triangle. And notice that angle is preserved here. So this angle measure is the exact same angle measure as this one. And now I have my 2 points. I have this point A prime and D prime right here. Those are my 2 points that I need to make my parallel line. So now I'm going to grab my line tool. And I'm going to hide this blue point here just to show, oops, I don't want to hide C. There's C. That blue point was just mapped on top of C. But here's a parallel line because we transformed this angle to its corresponding position here, right? And I could have chose any angle, really. Couldn't I have chosen, say, this angle? And notice now we still have corresponding angles here, right? And no matter what our triangles look like, those angles right here are the same, and that's really what's important. Okay, let's try another one here. Same idea, but now we're going to use alternate interior angles. So I need a transversal. It's going to go through C, so I'm going to use C, and now I'll just use point A. Okay, so now I have two options for alternate interior angles. If I want to highlight, say, this angle here, then I'm going to rotate it so that it comes to this angle over here. Or if I choose this angle here, I'll just rotate it to make this angle over here. It doesn't really matter. We have options, so I'm going to grab that polygon tool so I can capture this angle here. So I'm going to do, say, this angle right here. Okay, so we want to use alternate interior angles, so I need to get this triangle, this angle really that's important right here, to rotate to be this angle right here. So what I'm going to do is, since we want a rotation, A, the vertex of this angle is going to rotate to C, right? It's the vertex of this angle down here. So that's a straight line. Therefore, it's got to be that 180 degree rotation. And then the center rotation has to be the same distance between A and C. Therefore, it's got to be the midpoint between A and C. So I'm going to go to my my point toolbox, and in there we have a midpoint or center tool. So I'm going to click on that, and I'm going to click on A, and then I'm going to click on C, and that'll actually put the midpoint right between A and C. So that's going to be my center of rotation. So I'm going to go to my transformation toolbox. I'm going to grab my rotate tool. Now I can just click on my triangle here. That's really that angle. That's really what we're thinking about. We're going to rotate it around F 180 degrees. Make sure it's 180 degrees. And it doesn't matter if we go clockwise or counterclockwise, because that's a half of a revolution, right? So either direction get us to the same spot. So notice now we have this angle. I'm going to change my triangle up a little bit. So notice how we have this angle right here is now rotated to this angle right here in alternate interior positions. And now we have the 2 points that we can use to make a parallel line. So that's how we can consider transformations in constructing parallel lines using our angle pairs. So good luck with your assignment, guys. I hope that made sense.